Programming Part 1. Section 2.8, while loops. So, loops are just blocks of code that get repeated until a condition is met. So you're still going to have a Boolean that controls the flow, but unlike the if-else statements, an if-else statement checks the condition one time and just keeps going. A loop is going to check the condition, do the code, and then go back and check the condition again. It's going to keep doing that until the condition is false. Every time that loop runs, we call that an iteration. And the condition that lets us break out of the loop is called the loop continuation condition. So there are really three big types of loops. There's a while loop, a do while loop, and a for loop. Okay, in this section, we're going to focus on the while and do while. So a while loop is good when you don't know how many iterations you're going to need. It can be used if you do know the number of iterations, but it can also be used when you don't know the number of iterations. For instance, in the example up here, I'm going to keep rolling a die until I get an even number. That might happen on the first roll. That might happen on the 10th roll. We don't know. So we would have to keep looping until that condition is met. The difference between a do while and a while loop is the while loop checks the condition before it ever runs the loop. So it's possible that the loop doesn't get run at all. If you want to guarantee that the loop gets run at least once, then a do while loop is used. A do while loop does the execution and then checks the Boolean. Okay, so the while loop checks it first, the do while checks it last. And then the for loop we're going to look at in the next section. That's going to be used when you know how many iterations you're going to use. So for instance, like if you're rolling the die, you're not going to keep rolling until you get a number. You're going to say, I'm going to roll this die 10 times. And I'm going to count how many sixes I get. So you'll know how many iterations you have going into a for loop. Okay, so that'll be in the next lesson. Sorry guys, my mouse is not working. All right, so here's an example of a while loop. Now I like to, when I trace while loops and for loops, I use tables. When I first started teaching computer science, I didn't use a table the first day, and the students were like, what just happened? Then so I come in the second day and I'm like, okay, here's a table. These are our loop iterations. This is what's going there. And they're like, oh. So I'm a big table user, so you're going to see me using tables in these notes. All right, so let's just kind of see what's going on here. Okay, and then I'll show you the table afterwards. Okay, so here we have n is 31, m is 3. Is 31 mod 3 not equal to 0? So remember, mod is the remainder. So this is 3 goes into 31 10 times with a remainder of 1. So this is 1, which is not equal to, so that's true. Okay, so that's true, which means it's going to print the value of n, and then it's going to change n to 31 divided by 3. Now remember, because these are integers, this is integer division, so this is 10. So this all happens in the first iteration. This is all going on in iteration 1. So unlike the selection statements, when this is done, it's going to go back and loop up to this point. It's going to check this condition again. So now n has been updated. Is 10, right, our new n value, mod 3, not equal to 0. So 3 goes into 10 3 times with a remainder of 1, so this is true. So it's going to print 10, our n value, and it's going to set n equal to 10 integer division 3. Okay, so this is iteration 2. And then it's going to loop back up. So it's going to keep doing this until that condition is met. So let's see. I hope I don't run out of room here. Is 3, oh no, we're good. Is 3 mod 3 not equal to 0? 3 mod 3 is 0 because 3 goes into 3 one time with a remainder of 0. So this is now false, which means we're done with the loop. We don't execute it. That's not, there's no other iteration. So this only iterated twice. Okay, so if I go to the next slide, I can kind of show you that. So here's how I would set up the table. You could have a column that represents what iteration you're on. That's just a counter. This is our loop continuation condition. So notice that the n is what's changing each time. So what you would probably want to do here is you would want to keep up with your n. The m actually stays as 3 the whole time. You could have a column for m if you'd like, since both of those are showing up here in the loop continuation condition. But n is definitely one we need to focus on. So see how it started at 31. Then we checked our condition. It was true, so we printed 31 and we did the integer division. So all those steps that we did previously are shown in this table. It's just another way to format it. When I actually give tests to my students, their tests are on paper, I give them a table and they have to fill out the table. So that's actually one of the things I do require from my students to make sure I see their thought process. So the just to kind of show you, the do while loop is going to look almost identical. The only difference is instead of the while loop being up here, it's going to just say do, have the same stuff, and then put the while at the end. So what it does is it does the process. So it will always do the loop at least once. It'll do the process and then check the Boolean. So notice in the table, the Boolean check is actually near the end instead of near the beginning. Again, the main thing is, why would you use a do while loop if you wanted to guarantee one loop? That's the reason. Essentially, they give you the same output as long as the loop runs. We can combine things. Okay, so we have loops, we have selection statements. Well, they get put together. I mean, those are really the building blocks of our code. So here's an example where we have a loop. The loop continuation condition is this count. Okay, and notice if your loop continuation condition has a variable, well, it will have a variable, it needs to be initialized and it needs to be changed inside the loop. If you don't do that, you're going to get an error. All right, so here count is set to 5. Okay, so is 5 less than 20? And that is true. Okay, so iteration 1, we have a true condition. We go into the loop. I'm going to indent this because this is that if-else part. Okay, is 5 mod 3 equal to 0? So 3 goes into 5 once with a remainder of 2. 2 is not equal to 0, so this is false. So because that's false, we're going to do the else part. Okay, so we're going to set x equal to count, which was 5, minus 2. So x is now set to 3. We're going to print the x value, 3. And then we're going to change our count to be the old count, which is 5 plus 4. So this is now 9. All of that is iteration 1. So we're going to have to do that every iteration. So again, once it gets to this, right, it's going to go back to the while loop. We're going to have to do it again. Okay, our count is now 9. So is 9 less than 20? True. So it's going to go into the loop. It's going to check this first condition. Is 9 mod 3 equal to 0? Well, 3 goes into 9 3 times with a remainder of 0. So this is true. So this time it's going to do the if part, not the else part. Okay, so x is going to be set equal to 0. It's going to print 0. It's going to change count to 9 plus 4, which is 13. So this is all happening in iteration 2. So you're going to continue this process. You're going to continue this process until count is no longer less than 20. All right, so here's the table. The table shows us, we started with the 5. We checked the condition. We checked the if condition. And I even wrote on here which one got done. Was it the if part or the else part? So remember for the first one, right, if you go back, the else part was done. Okay. The else part was done. So x was set equal to 5 minus 2, which was 3. And that's what got printed. I bold-faced the printed stuff. All right, and then we went through iteration 2. Iteration 3, so what would happen for iteration 3 is our count is 13. 13 is is less than 20, so that's true. It would check the condition 13 mod 3. It's not equal to 0, so it does the else part. So x is equal to count 13 minus 2. It's going to print 11. And it's going to change our count to 13 plus 4. So that's where the 17 comes from. Notice your count. You could actually build this table just with the count. Okay, so count started at 5. We're going to continue doing this as long as count is less than 20. So all of these counts in the white space are less than 20. And count is always incremented by 4. So 5 plus 4 is 9. 9 plus 4 is 13. So sometimes that helps students too. Before they worry about the stuff inside the loop, they might build the table so they know how many iterations they are supposed to do. So you can use your count variable, which is your loop variable here. Look at the initial value, look at the condition, and look at the change. And build just this column. Once they build this column, then maybe they can worry about the rest. Okay, whichever's easiest for them. Some people like to do row by row, and then I have some students that like to build out their column for their loop variable and then fill in the rest. So it just kind of depends on the student. Okay, so here is an example of a while statement with some if-else inside of it, some nested if-else. Go ahead and pause the video, try to trace this code, and then come back when you're ready. Okay, so here what I did was I built the table. So count started at 12. I'm going to continue doing this as long as count is greater than or equal to 0. So 0 is okay. And notice at the very bottom here, so I kind of just, ignore this rest, right, for a little bit. Count is equal to itself minus 3. So what we're doing every time we do an iteration, we're decrementing count by 3. So if count started at 12, then it would be 9, then 6, then 3, then 0. Negative 3 is when it would break out of the loop, so that's not a real iteration here. Okay, so it goes basically from 12 through 0 for the loop. So when count is 12, check to see if it's this is checking to see if it's even, right? If it mod 2 is 0, that means it's an even number. It is. So x gets set equal to 12. And we print that. Count is now 9. So we go back to the loop. 9 is greater than or equal to 0. Is 9 even? No. This should be false, not true. Let me fix that real quick. Actually, I'm sorry. It is right because that's the loop condition. This is the loop condition being met. The if-else statement is checking if it's even or odd. So the loop condition is true, but the if condition is false. So what it would do the else part, right? It would do 2 times 9 from right here. And that's going to give us 18. And again, that gets printed. And it's going to continue in this format. And it's a pattern. Sometimes after a couple iterations of the loop, you might be able to kind of see the pattern, and that'll help continue on with the table. But again, the loop is going to run as long as that condition count greater than or equal to 0 is true. Once we get to negative 3 for count, it's going to break out of this loop. That is not an iteration. Nothing happens. It goes back to it would continue. If there was more code below the loop, it would continue with that.